Video course on statistics. From basics to advanced subjects. Dr. Yahya El-Maghazi, Professor Emeritus at Auburn University, Alabama, USA. Former Dean of Science, Technology, Math, Engineering at Ocean County College, New Jersey. A visiting professor at a number of universities including Rowan University, Keene University, and Montclair University, New Jersey, USA. Inferential Statistics. Part 6. Hypothesis testing for population proportion.
Well, this session is a little bit different, although it's a continuation of the previous few sessions. This time is about hypothesis test dealing with proportion. And proportion is one common applications that we see all the time. When people go to the election, they can vote for one candidate versus the other. When people fill in a survey of some form, there is a proportion of people that may agree or disagree of some political or economical issue. TV rating, there are proportion of people that will prefer one show over the other. If we are interested in surveying college students to see whether we have a majority of some gender or ethnic groups, for example. So dealing with proportion is a very, very common application of hypothesis testing. If we go to more applications in manufacturing, the proportion of rejects or defects. So you can see that there is a wide range of applications of proportion. Early on, we were able to estimate intervals or confidence intervals associated with proportion. This time, we will test hypotheses associated with proportions. The general form of hypothesis test for a population proportion will look like this one here in the slides. What we have here is a null hypothesis that deal with proportion P0, which is a proportion about the population. Keep that in mind. Keep in mind that we are always testing the population, not a sample. And the alternative will be P not equal P0. Another form would be P less than P0 as the null hypothesis, or P greater than P0 as the alternative. A third way to do it is H0 or the null hypothesis P greater than P0 or P less than P0. The basic rules is for large N and P not too near 0 or 1, we can assume that P is approximately normally distributed. So if we have a large sample size or large number of inspected or surveyed people, and provided that the probability value not too near 0 or 1, we can assume that P is normally distributed with an average mu P of P and variance of P times 1 minus P divided by N. The rule of thumb is if NP, that is the sample size times the probability, and by the way, these are the two key parameters of a binomial distribution, if you recall. If NP is greater than or equal 5, and NQ, and the Q is really 1 minus P, is greater than or equal 5 for a variable following a binomial distribution, we can assume that the sampling distribution of proportion is normal with a mu value or average of P and variance of P times 1 minus P divided by N. Now, the significance of this assumption is that it's going to lead us to something that we are very familiar with, which is the use of the Z statistic in testing hypothesis of proportion. So the Z statistics is valid on that basis. The Z statistics is valid on that assumption that NP or NQ are greater than or equal 5. And in this case, the Z statistics is calculated by P hat, which is the estimate of B, as we mentioned in earlier session, minus the claimed value, P, divided by the square root of P times 1 minus P divided by N. So what's P hat? It's a sample proportion from the sample. And sometimes we call it the estimation of the population mean, as we did before. Sigma P hat is the population standard deviation, is an estimate of the population standard deviation. And N is the sample size. Let's take an example here. A company surveys its employees on their willingness to pay a cost share of $50 per month for providing company transportation to and from work. We're familiar with this example by now. Now here, the company is asking its employees to have a cost share, to pay some. That's $50 per month for providing company transportation to and from work. The company would also offer the service if at least 80% of employees will use it. So using a sample of 800 employees, 520 people agreed to use the service. That's agreed to go for a company transportation versus their own transportation. Keep in mind that this 80% will have to also agree to pay the $50 share. Now, taking a sample of 800, and out of which we have 520, then we have a proportion. And the best way to illustrate that using a hypothesis test is a null hypothesis of P greater than 0.8 or greater than 80%, which the company would like to have in order to provide this service, and that's a hope claim in this case. And the alternative will be that P is less than 80%, at which case the company unfortunately will not provide the transportation service. So you can see the practical essence of this hypothesis test, because based on the decision of this hypothesis test, the company will decide to either offer the service or not to offer it. Now, the estimate of the population proportion based on the sample of 800 can be calculated by dividing the 520 people that agreed to the service by the total number of people that have been surveyed. That's the 800. So 520 divided by 800 will give us the estimate P, or the estimation of the proportion of the population from the sample. And as you can see here, we have 0.65, or only 65% of the people will agree to this service. Now, in most practical applications, a company will stop here and say 65%, that's not enough, and we will not provide the service. While the right way to do that is to continue with the estimation or the hypothesis test analysis in order to have confidence on the decision that we are making. So here we have the hypothesis test format, P greater than or equal 0.8, that's the hope, and the alternative is less than 0.8, and we have the proportion from the sample. And now we can calculate, of course, we have to see whether the condition of NP greater than or equal 5 or NQ greater than equal 5 is satisfied. And here it's way satisfied because NP is 640 and NQ is 160. So now we can use the Z statistic. And the Z statistic is simply P hat minus P, or the claimed value, divided by the square root of P times Q, or times 1 minus P divided by N. And we have all what it takes. We have 0.65 from the sample. We have the claimed value of 0.8. And we have the sample size of 800, and that gives us a value of Z0 of exceptionally high value of minus 10.6. Now, if we go to the normal distribution, and since this is a one-sided test, and since we know that at 99% or 0.01 one-sided, we will have a Z value, critical value of minus 2.33, and you can see how you get that from the normal table. Comparing this to our Z statistics, which will be way out of this entire area, minus 10.6, will be way out of the normal curve, as you can see here, meaning that we are for sure at the reject area. So we're definitely going to have to reject that the proportion of people agreeing to the surface is equal or greater than 80%. So that is one way to perform the test, meaning that we're going to have to tell the company, sorry, the percent is not greater or equal 0.8 and the surface cannot be provided at the $50 cost share. So that's a no-go decision. Suppose, on the other hand, the company, given that result of the hypothesis test, decided to go down on the cost share. So instead of $50, the company has decided that employee will only pay $30 per month. And they repeated the survey. But this time, to save time, they only used 100 people. And out of the 100, they found that 78 people agreed to the surface. We have the same claim because they need the 80% threshold in order to provide the surface. And we have a new proportion of 0.78, given the fact that now, after reducing the cost share, more people were attracted to the surface. So now we have 78 over 100 of 0.78. Now the question here, for some companies, 0.78 sounds very low compared to the 80%. So if you don't continue with the hypothesis test analysis, you may still decide not to offer the surface because 0.78 is less than 0.8. Let us continue the test and see if this will hold true in this case. Here is the Z value. And the Z value, we have all the statistics that needed to calculate the Z value. It's the 0.78 new proportion minus the claimed value divided by the standard error, or 0.8 times 0.2 divided by 100. Notice that the 0.2 is 1 minus 0.8. And now we have a Z statistics of minus 0.5. Now, the critical value is still the same at 2.33. The reason for that is we still have the same type of error, type 1 error that we are still willing to commit, which is 1%. But this time, look at the Z0. The Z0 is right here, meaning that we cannot reject the null hypothesis that the percent is greater than or equal 80%. Meaning that the surface will have to be provided, and that's a go option here. It's very important that we really look at these two examples and compare between the two. Always question the decision, as if you don't, people will. So before we make that decision, we need to know what made the difference. And obviously in this simple case, what made the difference is the cost share at one time was $50, and now it is $30. When it was $50, the proportion was 0.65. The Z statistics was minus 10.6, and the Z alpha is minus 2.33, and as a result of comparison, we have to reject. When the cost share became 30, the proportion was 0.78, the Z statistics is minus 0.5, the Z alpha is still minus 2.33, so we have to fail to reject. So there is a no-go and there is a go options or approach as a result of the fact that we have changed the cost share. Now, one can still question this. In the first case, we've used a sample of 800. In the second case, we used a sample of only 100. can this affect the decision? It's very important that we think of the factors that can indeed affect the decision of any hypothesis test. In general, if you select a sample that is not representative of the population, then you're more than likely going to make the wrong decision. And you indeed may be committing either type 1 or type 2 error. The second, if you select the wrong sample size, meaning if you decided to do a sample size that is less than the threshold that we discussed in previous sessions, then you may be committing type 1 error. As I said earlier, in order to avoid committing type 1 and type 2, hopefully simultaneously, you need to do as much or as large a sample as you can get. Also, if your population variability is high, then you need to increase the sample size. And you need to be more careful in selecting your samples to avoid committing type 1 or type 2 errors. Definitely, the decision may vary depending on your selection of the sample size, and the population variability. These are the three key criteria that we have to meet very carefully in order to make the appropriate decision in any test of hypothesis that we deal with. If we don't meet this criteria, then we very likely will not make the right decision. And as you can see in this last example, the decision was not just about the percent of people that will join the service or not, but also was about cost. And most of the time we deal with decisions that yes or no can make or break an organization cost-wise or expenses-wise. So we really have to be very careful in performing hypothesis test. A business consultant firm claims that about 42% of working people prefer a certain retirement plan, coded X23. A large company surveyed a representative random sample of 600 people of its employees regarding this retirement plan. The result of this survey revealed that 235 of employees prefer the plan. We need to test the claim on the basis of this information and the type 1 error of 5%. Here we have all the information we need. We have the sample size n equals 600. We have the number of people that agreed to the plan, 235 people. We have the claimed value of 0.42 or 42%. We have the type 1 error 0.05. And the null hypothesis will be H0 P equal P0, or the claimed value, and H1 or the alternative hypothesis will be P not equal P0. So H0 or the null hypothesis will be P equal 0.42. The alternative hypothesis will be P not equal 0.42. Now step 2, we calculate the sample statistics. Since we have 235 people out of 600 agree to the plan, that gives us a point estimate or a proportion of a sample of 0.39. We also know the sample size. And we also know type 1 error or 0.05, which means the corresponding Z value is 1.96, as you recall. Here we calculate the Z statistic. And as you can see, the Z statistics is the P hat, which is 0.39, minus the claimed value of 0.42 divided by the standard error. 0.42 times 1 minus 0.42 divided by 600 square root, and that gives us a Z statistics of 1.489. That's minus 1.489. So now we need to compare this calculated Z statistic with the critical value to see whether we will reject or accept the null hypothesis. And as you can see here, here is the sketching of the normal distribution. The critical values are 196 plus to 196 minus, and the value of the Z statistics comes in the do not reject area. So as a result, we have to not reject the null hypothesis that the proportion is actually 42% or 0.42. Now let us bridge now to the estimation aspect. Now we have n equals 600. We have the point estimate 0.39. We have the Q estimate, or the Q value 1 minus P hat, which is 0.61. So we can calculate the standard error. We know that a critical value of 95%, the Z value is 1.96. Our estimation is P equal P hat plus or minus Z times the standard error. P hat is 0.39. Z value is 1.96. Standard error is 0.0199. So now we have a point estimate of 0.39 plus or minus a margin of error of 0.039, or the range should be 35.1% to 42.9%. And one more time, this value here is the margin of error, and the percent, the margin of error, is obtained by dividing this by the point estimate times 100, which give us 10%. And again, what does that mean? It means, if you recall, we did not reject the null hypothesis of the proportional population being 0.42. Now, is 0.42 fall within the interval estimate? Yes, it does, because the interval estimate is from 0.351 to 0.429. And since we did not reject the null hypothesis that P equal 0.42, then we definitely made the right decision. I hope after these 3-4 sessions that we introduced, that you can get the sense of the importance of hypothesis testing. Obviously, in a short session, we cannot cover but a limited number of examples. Textbooks have many examples. The book that's assigned have many examples that you want to look, and many practice that you want to make, but you also do not want to lose sight of the practical aspects of inferential statistics and the hypothesis testing. In the next sessions, we will move on to more important issues of hypothesis testing, where we will have to compare between two populations. Until then, we'll see you.